In our last section, we learned how to graph parabolas in vertex form. And vertex form is great because it uses rules that you guys have already learned and practiced. Moving the graph left, right, up, or down lets us see where the vertex of the graph is going to be, and then we just use the a value to get our other points. Now, in this section, we're going to be talking about graphing in standard form. Standard form, again, being our ax squared plus bx plus c. Now, the rules that we've learned already do not apply, the left, right, up, down stuff does not apply to graphs in standard form. So this graph right here is not right 2, up 1, or something like that. The reason for that, in our last section, when we were graphing things, here's our vertex form that we did, there was only one x in the problem. It's being moved right 1, up 3, left 4, down 1. There's only one x in each of those equations. Unfortunately for us in these equations, there's x in multiple spots. There's an x here and here. There's 2 in this one as well. It doesn't work like that when you have multiple x's. So what you need to do is find an alternative way to graph these parabolas. Now in this video, I'm going to talk about how you find the vertex of the parabola in standard form. If you don't know where the vertex goes, you're not going to be able to make the graph because you won't know where to start it. So in purple here, I have written a little mini formula, negative b over 2a. Also, sometimes you'll hear opposite b over 2a. This little formula gives you the x coordinate of your vertex. So if we look at the a, you see an a and b here. The a refers to the number in front of the x squared. The b refers to the number in front of the x. We're going to do this formula. We're going to get our x coordinate for the vertex, and then we're going to plug it in to get the y coordinates. So I have 2 examples on this, and for this first one here, I'm going to go ahead and write down what my a and b are off to the side here. You don't necessarily have to do this, but it doesn't hurt to have it on there. A is the number in front of the x squared, and in this one we have a 1x squared. So my a is 1, and b is the number in front of x. I have a negative 2 there. So the little formula says I need to do opposite b, or negative b, over 2a. So I'm going to do negative, because the negative's already there, and then negative 2. In other words, a positive 2, because the negatives are going to cancel. That's why it's called opposite b, because you're basically just changing the sign in whatever b was. So I'm going to end up with positive 2 over 2 times a in this problem is a 1. So I really have a 2 over 2, which is equal to 1. If you were to type this in the calculator, make sure you do the whole bottom first, like multiply this out and get a 2, and then do 2 divided by 2. If you leave it separate like this, where you just do 2 divided by 2 times 1, it won't always work out, so you want to make sure that you do the top, do the bottom, and then divide. So anyway, we got our 1 here, and as I wrote up here, this is the x coordinates of my vertex. So my vertex for this problem, this first one right here of that graph, is going to be at 1, comma, something. Don't know what it is yet. All you do is you do negative b over 2a, you get your x coordinate. Now we just plug it back in, and we're going to get our y coordinates. So I'm going to plug in a 1 for x, that means I plug in a 1 here and here. And if I do that, I'm going to get 1 squared minus 2 times 1 plus 1. I can either use my calculator, or I can just do it mentally. It looks like you'll get a 0 out from that. So my vertex is at 1, comma, 0. And I have one more problem to practice on this. Same sort of deal. If you want to find the vertex, like the instructions ask, we're going to do negative b over 2a. So in this problem, my b is a positive 10, so I'm going to do negative 10 up top, over 2 times my a in this one is negative 2. I'm going to do my bottom part right here, so I can type it in the calculator. I get negative 10 over negative 4. Which is a 2.5 if you divide that out. So I know my vertex in this one, it's not a whole number, but it's going to be at 2.5, comma, something. Don't know what that is yet. And the way I figure it out, same way as before, I'm going to plug in a positive 2.5 for x here and here, and I'm just going to see what I get when I do that. So if I plug that in, according to my calculator here, the answer is 8.5. So my vertex is 2.5, comma, 8.5.